All right, I'm going to go ahead and get started. So welcome to Webinar Wednesday. This week we are going to be talking about Creo Sheetmetal design. So just a quick agenda before we get started today. Essentially, I'm going to give first a little introduction and then jump into kind of a general overview of sheet metal design. I'm going to talk just a little bit about the basic features such as walls, bends, and forms. And I'm going to talk about bend order tables and detailing. So essentially how you're going to actually put this into a final drawing. And I'm going to talk about what's new in Creo 7. So just the little changes that have recently been made to improve this software. And then in the second half of this webinar, I'm going to do a short demonstration just showing how working with a sheet metal part works in Creo in real time. Lastly, I'll open it up to a Q&A if anybody has any questions. So just a little bit about myself. My name is Sevi Beaver. I've been at Boundary for about 1.5 years, and I have about 7 years of various CAD experience. And I come from a mechanical engineering background. A little bit about Boundary. They are a technology leader with mostly PTC software, but working with some other software as well. To the right is just a list of some of the companies that we work with. We are a platinum partner with PTC. So what that means is in areas with Creo, Windchill, MathCAD, Arbortext, we offer services, we offer classes, we offer consulting, we offer pretty much everything we can relating to PTC products. In addition to PTC products, we do have a few others. Some of the ones that we work with are shown here. All right, so with that intro aside, we are going to move on to sheet metal. So first of all, what is sheet metal and why do we use it? So Creo Sheetmetal is built directly into Creo Parametric, and it is essentially used to model a certain scenario that happens really often in real life, which is working with material that has a constant thickness. So in this situation, performing any kind of bend or any kind of feature operation will change the length of the sheet you're working with. So in essence, your initial length and your developed length that you'll end up with after your whole development process is done are going to be different, and that's going to depend on what material you use. So the main benefit of using this program is that all of these length calculations are done inside of Creo. There are multiple ways to calculate this. Without going into it with too much detail, various parameters can be manually set in Creo, or you can just select the material you're going to use, and Creo will model it very, very accurately. So some of the things that Creo Sheetmetal can do that are pretty useful. First of all is a flat pattern. Essentially, you can build your sheet metal parts for in the formed shape. So essentially, how it's going to look when it's all completed. And then you can create a flat pattern, which essentially shows the flat piece of sheet metal that will be used to create that. You can create that. You can see how any changes you might perform will change the flat pattern as well. Next, you can do detailing. This is exactly like making a drawing in Creo Parametric. And the main things you're going to be showing in a sheet metal drawing can be the flat and form state, The dimensions, the bend line notes. So for example, in a flat state, you can say this bend will be performed at a certain number of degrees. And bend order tables, which can indicate the order in which the bends are performed, which can oftentimes be essential to make the part fit together properly. So the features and tools that you'll use in sheet metal to create the models of your parts. The first is going to be a primary wall. You can make these through planar, extruded, revolved, blend, or offset methods. Essentially, those are just ways to determine the shape of the initial sheet metal plane that you're going to be working with. From there, you can make secondary walls that essentially come off from that primary wall. And those can be made in all of the same ways as primary walls through those initial methods, and additionally through the flat and flange tools inside of the software. They just kind of make it easier to make a secondary wall based on the profile from either the side or the horizontal view. So once the main walls are created, you can go ahead and add features to those walls. The main features include bends, which are exactly as they sound. They model a bend performed in the real world using various bending methods at various angles. Additionally, you can do form presses, cuts, and you can arrange these features in numerous different patterns. And lastly, you can modify corner relief. You can customize how the material will be distributed between two different parts of a corner, how it will fit together, if it will be rounded off, etc. So that covers essentially the basic design process and how Creo Sheetmetal works. Creo 7, there was a small improvement. First of all, multi-body design was added to Creo 7 as a whole, and this is fully implemented in sheet metal as well. Additionally, for form features, they are improved in that the geometry will be more accurate. And additionally, there's an option that you can see on the right to trim edges sheared. Is just a checkbox you can check now to enable that edge to line up with the wall. All right, so I'm going to go ahead and jump into my demonstration. So I'm in Creo Parametric here, and I have a snowmobile assembly. This assembly has multiple sub-assemblies, sub-sub-assemblies, and even some sub-sub-sub-assemblies. Additionally, it contains normal parts and sheet metal parts alike. So I'm just quickly going to change a couple display settings here. And just going into the chassis subassembly, and then a sub-subassembly. I'm just going to go ahead and open this. Now this sub-subassembly has two assemblies inside of it, and additionally a normal part and a sheet metal part. So the first thing I'm going to do is I'm going to go ahead and add a couple parts to this. So first, I'm actually going to bring in a SolidWorks assembly. Creo Sheetmetal is completely integrated with not only non-sheet metal parts, but any kind of part or assembly from supported other 3D modeling programs. So I just went ahead and assembled that into here. Now I'm going to bring in, once again, another part. This time I'm just going to bring in another sheet metal part that I had made previously. And to assemble this, I'm just going to align the coordinate systems there and lock that into place. So this part right here that I just brought in, it's a pretty simple sheet metal part. So if I just activate this and take a look at the model tree, we can see that this sheet metal part was created with an extrude, which was then converted to sheet metal. So essentially, when you create a new file, you can designate a sheet metal part, or you can simply create a normal part file and convert that to sheet metal. So this first wall, this primary wall, was actually converted from an extrude. We then have a bend performed right there, I believe at 30 degrees. We can see that one wall is extended and a secondary wall is additionally formed in another direction. We have two secondary walls, flanges here, and we have two flats. These are very similar in what they do and what they look like. They're just a little bit different in which dimension you can change to create them. And lastly, we have a form right here that was sketched. And there was a move performed via flexible modeling, which is no problem either. So what I'm going to do, I'm just going to make a couple modifications to this. First, I'll go ahead and just extend this this wall here. So I'm just going to go ahead and use that extend tool to pull that and be parallel with the other end of this part. And next, I'm actually going to create a third wall here. So I'm just going to create another flat. I'm going to change this distance here. Essentially to just act like this other edge and kind of grab onto this tool from another angle. Excuse me. And that about does it for that. So lastly, I am going to just show how to implement a couple additional features, such as the as an extruded cut or a punch or something like that. So with that, I'm just going to activate this other sheet metal part. And if we see in the model tree, I have a sketch 3 already drawn here, just to describe the kind of cuts that I may want to make into this part. So I'm just going to go ahead and use this extruded cut feature. Looks like something's failing to regenerate. There we go. And we can see that it's very simple to just create features from sketches similar to Creo Parametric. So I'm just going to go ahead and actually delete this. So next I'm going to create a punch form. I can do this either from File or from various generic Creo models that are already built into the software. So I'm just going to quickly pick one from File. Just 1 second, sorry about that. There we go. So I'm just going to go ahead and place this on the surface. Similar to placing a hole in Creo Parametric, these little reference grabbers can just be used to set your distances and place this. So I'm just going to go ahead and set these values and place my punch form. And next I'm just going to make a pattern. So I just want this punch form to be patterned in this area. And I actually already have a sketch, which I'll go ahead and show you all, just designating the area that I want this pattern to fill. So going back to selecting this feature and making a pattern, I'm going to change this to a fill pattern and select my sketch. I'm just changing some of these dimensions here. And now we can see that my punch form was patterned all across that fill area. So like Creo Parametric, it's fairly easy to create these features and create patterns, groups, etc. All right, so the last thing I want to show, I'm going to go ahead and open this part separately. And we can see in the model tree, I have a flat pattern of this part suppressed. So I'm going to go ahead and activate that. And we can see that it takes this very complex part with lots of bends at very weird angles and generates a very accurate 2D, essentially, flat representation. So this is the size of sheet metal you would actually need. This is how you would perform the cuts, how you would perform the bends, and that is essentially the usefulness of this software. So I'm going to go ahead and suppress this again. If I click this little icon in the graphics toolbar, we can see that I have a flat pattern preview here. This acts as a window that you can just see in real time that will update as you make any changes to your model. And this will allow you to see the flat pattern and how it would look. One thing to note, I'm going to go ahead and close out of that. If you use multiple monitors or just like things in multiple windows, there is a configuration setting. It is called accessory window display. So if I change this from docs to undocked, we can see that this this flat preview now shows up in a separate window. So if I was to have another monitor, I could drag this off screen. And if I just arranged like that in kind of how Windows does it. You can kind of see how it would look on multiple screens to have the flat preview right there in real time. All right, so just a second, there we go. So that does it for the presentation today. That covers the basics of Creo sheet metal design. I'm gonna go ahead and open it up to any questions. You can find questions in the GoToWebinar window. And we have plenty of time, so I should be able to answer any questions that get submitted. Looks like I'm getting a whole lot of questions, so I'm going to give people a couple more minutes to submit those. And I may actually have to get with some people afterwards individually, but I will definitely contact you by email by the end of the day with some kind of message if I don't get to your question here. Okay, I'm going to go ahead and start addressing some of these questions. So what version of Creo am I using? I'm using 7.0.0.0, so not the newest release of Creo 7, which I haven't gotten around to picking up actually, which I believe is just bug fixes at this point, with the next major update expected soon, but don't quote me on that. As far as new features for Creo 7 sheet metal that may make the tutorial different for users of different versions. There's a little change in what I believe what's listed in the quick access toolbar. So what's on your left click, essentially, which options pop up. So if something tells you to click an option there, you may want to make sure it's the right option. But besides that, the core functionality of Creo Sheetmetal is relatively unchanged for a while. They generally add little updates and tools, but any tutorial, I've at least done the one back to Creo 2, and it's essentially the all the skills and features and settings carry over for the most part. So there are some people that are looking for some additional topics to be covered. We have a question: is there time to show how to create a punch from scratch? So I assume you mean the punch itself. I think not right now, but I can definitely get with you and show you how to do that. As far as a review of how to generally just get started, create some walls, get going from scratch. Yes, I can actually show that in just a second. Let's see what else we got here. Can the K factor be adjusted? Yes. So this is relating to how Creo calculates that length. That is essentially, it's going to change every time you make a bend or something like that. And it varies per material and also due to specific manufacturing processes as well, which is why people might want to customize that. So yes, I believe there's another variable besides the K factor as well that can be adjusted in Creo. And that is just, I believe, for one of the many formulas that you can use to calculate this. I don't have much experience with the other formulas, but I know that they are available. What is the preferred way to show a flat pattern on the same drawing as a form part? As far as the kind of the industry standard way, I'm not entirely sure, and I will get in touch with a person at my company that would know that and get back to you. Same with thoughts on bend tables for globally fabricated parts. That's something that I will get in touch with you over email, and I think that would be a better way to provide that. Let's see what else I missed. Accessory window display config available in Creo 4. Yes, as far as I know. Yes. When did they add the fill pattern option? That's a good question. It might have been semi-recently. Kind of been somewhere around Creo 4, but I really have no idea. I will definitely look into that and get back to you. Is the real-time flat pattern update window a new feature in Creo 7? It's not. I know it's in Creo 6. As far as when it was new, I'm not positive. I want to say Creo 5 or 6, but I don't know for sure. So I will confirm that and get back to you as well. Am I using the default pen table? I am. I don't know about our other main sheet metal guy that I'm going to talk to. I'm sure he is not using the default pen table. So that is definitely also something I will get back to you with. I actually believe most of the rest of these, besides the brief demonstration of how to just create a new sheet metal part and get up and running. I believe most of those are kind of specific questions, and I will be sure to contact each of you by email by the end of the day and talk about with a different additional information at least. Okay. So with that, I'm just gonna do a really quick start from scratch kind of thing, rather than starting from big assembly. Um, if you would like any additional help with this, by the way, happy to answer additional questions over email. So this is just going to be kind of a very brief overview. But this is how Creo is going to look right when you open it up. As I said, this is Creo 7. So I'm just erasing not displayed. So this is just clearing my memory from that last part I had open. You can see it took a second because it was a really big part, but now I'm all empty. So I'm going to click new part, and we can see here that I have some options. I have a solid or sheet metal as kind of sub options here. So I can create a sheet metal part right away, which will give me just different menu options and things like that, different functions that I can perform, or I can make a solid part and convert it to sheet metal later on. So for these purposes, I'm just going to go ahead and click subtype sheet metal. Okay, so when we load in here, we can see that we have the graphics window, main area, which is where whatever we make is going to show. We have toolbar up here that essentially shows various display options for this window. We have the model tree, which is going to show datum features. If I go ahead and enable those, we have planes, coordinate system, and bodies, which is actually new in Creo 7. This is where materials would show up as well if I assigned them. In the top, I have the various ribbons. You can see that they look different for a sheet metal part rather than normal solid part. If I want to convert, I can click this little operations drop down and convert to solid parts. So for now I'm in sheet metal. These are my various sheet metal functions. I have to create a primary wall first. So that's going to be usually from one of these options here. In my other ribbons, we have some various model sketching tools, basically how the solid parts modeling tools would look. And most of the other tabs are going to look rather similar. So if we go back to sheet metal, just going to create a quick planar primary wall on this this top plane. So if I draw a basic rectangle here, we can see that I have two new tabs here, a sketch tab, which is going to designate the sketch itself, so what it's going to look like. And when I accept that, we have the planar feature tab, which is going to take that sketch and turn it into this primary wall, and you're going to designate how thick it's going to be. So here we have the first wall, which I use that planar feature to make, and now you can see that we have these other options lit up, flat and flange. These are secondary wall options. We still have all the initial options available as well. Another important one is revolve, because it would be used to make a lot of circular type parts, which are or even circular cuts, etc., which are very common in manufacturing in general, I guess. So just to demonstrate a flat, if I click this edge, essentially I can set these parameters for my wall that I'm going to make, my secondary wall. These can be, I'm just going to quickly show with dragging, these can be the angle, additionally dimensions in certain ways. So with the flat feature, I can change these dimensions. And if I cancel this and make it a flange, the dimensions I change are in the plane of the direction, I guess. So in the plane of the cross section, rather than in the plane of the looking at the wall straight on like this. So that's kind of the difference in flange and flat, even though they're essentially used to create secondary walls all the same. All right, so I believe that covers kind of an intro to how to get into sheet metal, start making some walls, start messing around with it. Then if anybody has additional questions, I can be reached at sbeaver@boundarysys.com. Additionally, as I mentioned, for everybody who's already asked questions, I will be sure to get in contact with you by the end of the day to talk about those specifically. So thank you so much for your time and for attending Webinar Wednesday. And I hope you have a great rest of the week.